So for today, we're going to be doing what's called the fundamental principle of counting. You've probably done this before where you had trees, basically, kind of to figure out what was going on. And we're also going to be talking about permutations. Okay, so first off, the fundamental principle of counting basically shows you how many ways you can arrange things. Okay, so how many different outfits could you put together using 2 sweaters, 4 pair of pants, and 2 pair of shoes? So of the 3 things that we have sweaters, we have 2 of them. We have 4 pair of pants, and we have 2 pair of shoes. So if we start with the pants, since we have more of them, let's just number them pant number 1, pant number 2, pant number 3, and pants number 4. Okay, with each pant, you can put in a sweater. So sweater 1 and sweater 2. Now, with each sweater, you can put 2 pair of shoes. So each of these, we'll just put S1 and S2. So you can see my tree diagram here. It's getting rather crowded. So since you kind of understand the rest of what we're doing down here, I'm not going to put any more because it's going to be very difficult to see. Okay, so for each pair of pants, you have 2 different combinations you can wear with sweaters. So for 4 of these, you have 2 sweaters. So that gives you 1, 2, 3, 4, 5, 6, 7, 8 so far. Now, for each of those, you have 2 different pair of shoes you could put in that would make a different outfit. So if we continue with this pattern of creating 2 for each one of those, we're basically looking at 4 pair of pants times 2 sweaters times 2 different ways to wear shoes. So 4 times the 2 gives us the 8 combinations with the sweaters, and then add the shoes in here, or multiply the shoes in here, and you get a total of 16 different combinations of clothing, or arrangements, or orders. 16 different ways you can wear your clothes. Okay? So this is the fundamental principle of counting. It tells you the total number of ways you can do something. So as it says, the fundamental principle of counting says, suppose there are n ways of choosing one item and m ways of choosing a second item and p ways of choosing a third item, and so on. So you can do as many items as you want, and each of them will get a different letter. So the total number of possible outcomes. Now this would be, in a probability, this would be our denominator of our probability. Okay, so this would be n times m times p times however much else you're going to put in there. Okay, so you just keep multiplying however many items. So you're going to multiply the number, or the number in each type, in each section. So for us, our pants, our sweaters, and our shoes are the 3 different things, the 3 different sections, and we multiplied how many we had in each of those sections together. So that's our basic fundamental probability, and it usually will always give us the total number of possible outcomes. Okay, so since the probability of an event is the number of outcomes in the event, in the specific event, divided by the number of total possible outcomes. So for what we just did, this part here is our fundamental counting principle. Just the bottom. Okay, so suppose a license plate can have any 3 letters followed by any 4 digits. Okay, so we have a letter, a letter, a letter, a number, a number, a number, and a number. Okay, so we have 7 specific pieces that we're putting together. 3 of them are letters and 4 of them are numbers. So it asks us how many different possible plates are possible. When it says how many, this is going to be our counting principle. We're just counting how many things that can happen. Okay, so how many possible letters are there to choose from in the alphabet? Well, that would be 26. Since there are no restrictions on our letters, it says any 3 letters, so that would be 26 possible choices for each of those 3 spaces. Now, when it comes to numbers, you've got to be very careful when you're thinking about this, because it's a single digit, it's 1 digit, but you got to remember that 0 is a number, and it can go 0 through 9. So this is going to be 10 digits. So that means we're multiplying by 10 times 10 times 10 times 10. So get our calculator out and type in 26 times 26 times 26. Now, multiplying by 10, it's 1 with the same number of zeros. So this is 1, 1, 2, 3, 4. Makes it a little easier to type in. So we get 1, 7, 5, 7, 6, and 4 zeros. Putting in our commas, that gives us 175,760,000 different combinations of license plates. Now, since this is what Georgia does, 3 letters, 4 numbers, this is how many combinations of license plates you can have with that are basic license plates. Probably enough for the people who drive in Georgia. Okay, so let's move down to the next one. How many license plates are possible that have no repeated letters or digits? Okay, so this has a restriction. No repetition for letters or digits. So still asking how many, so still counting. But we have a restriction on this now. So instead of just doing 26, 26, 26, we have to think about what happens when we choose a letter and when we choose a number. Okay, so we still have 26 for the first space of our letters because we haven't chosen any yet. And now that we've chosen a letter, we can't repeat that letter, so now we have 25 to choose from, and then 24. So our 3 letters go down by 1 each time. And similarly with the numbers, we start with 10, but once we choose a number, we can't repeat it, so that would be a 9, and then an 8, and then a 7 for the 4 numbers. So each time we go down by 1. So again, going over to our calculator, we want to type it in. And that gives us 7, 8, 6, 2, 4, and 3 zeros. So this is 78,624 different ways we can do it if there's no repeated letters or numbers. So drops down a little bit when you put in a restriction. Now, the last thing is the probability. So the probability that a randomly selected license plate. So how many are we selecting? So the probability that we get 1 license plate that has this restriction of no repeated letters or digits. So that would be the probability of 1 over 78,624,000. And that would be our probability that we would select 1 license plate that has those repeated digits. So that would be the probability. Now, if we wanted to put that into decimal form, we would just divide 1 by this number and you would get the decimal. But it's going to be a really small decimal, so it's probably better to leave it here, because you're probably going to get way too many zeros before you get to an actual number. Okay. Now, permutations. So permutations are a way of arranging information in a particular order. So the order matters in a permutation. I have 5 books I want to arrange in a particular order on a shelf. Okay, so it's asking me how many different ways can I arrange them. So here's the thing. Once you put a book on the shelf, okay, book number 1, once you put it up there, you don't have it to choose from anymore. So the order is going to make a difference in how we put it up on the shelf, sorry. So once we choose that one, it's going to be a different order if we put that book in the back. So what we're looking at is we have 5 books to choose from for the first spot. We're arranging all 5 of them. So then we're going to have 4, and then we have 3, and then we have 2, and then we have 1 book left. So all 5 books, 5 spaces for these things in a particular order. Now, this particular type of permutation, where you're using all possible numbers in the thing, you have the same number of spaces as you do things to put in them, this is called a factorial. And we actually have a special key on the calculator that will do this for us. It is in the math menu. And it is, I believe, number 4 under probability. Go over to it's on the math key, going over to the probability menu. And number 4, you'll just see an exclamation point. That is the factorial. Only works when you go all the way down from the total number you have, all the way down to 1. This is the only time it works. So you can type in 5 factorial, okay, and you'll get the same number as if you multiplied the 5 numbers together that you have up here. So going to our calculator, we're going to type in 5, and go over to math, over to the probability menu, and number 4. So you see it says 5 with an exclamation point. So when I put it in there, I get 120. Now, if I multiply 5 times 4 times 3 times 2, and really don't have to do times 1, but just so it's in there, I also get 120. So you'll see that doing the factorial, as long as it goes from the total number all the way down to 1, you'll get the same answer as if you typed in all the numbers. It helps a lot when you have a larger amount of numbers to work with. Okay, so there's 120 different ways I can arrange 5 books on a shelf. Okay. Now, what if I only want to arrange 3 of the books on the shelf? I only have space for 3 of them up there. So I want to put 3 books out of my 5 on the shelf. So in this case, I only have 3 spaces to do. So to do this, I'm just going to start with 5, like we did with license plate. I have 5 to choose from. I've already chosen 1 for this spot, so that goes down by 1 for 4, and then it goes down by another 1 for 3. I don't have any more spaces, so I don't have any more numbers to multiply. So if we look at this, 5 times 4 is 20, 20 times 3 is 60. So I have 60 different ways to arrange 3 of the 5 books. Okay? Now, you can do it this way, but we have a key called a permutation key in the calculator. This is NPR. Okay, the N stands for the total number in the set. And the R stands for how many we want to choose. So if we're going to put it into the calculator, we would put in 5 that we're selecting from, P, and we're choosing 3 of them. So this is what it's going to look like, 5P3. So going up here to the calculator, let me get the larger view for some of you. Okay, so we're going to put in 5. We're going to go to math, go over to the probability menu, and number 2 here says NPR. That's what we're going to choose. So I'm going to pick number 2. Now, some of you, it won't show up in the box like this. You'll actually have 5, and then it'll say NPR, and then you're going to type in 3 because that's how many we're choosing. And then when you do that, you'll hit enter, and you'll see that we get 60, the same as if we did those little spaces. So you can see that if you do it in the calculator with our program, we get the same thing as if we multiplied them together by hand. So we get 60 different ways to arrange 3 of the 5 books. Okay, so whenever you want to, oh, I hate it when it does that. Whenever you want to know how many ways there are of arranging some number of items, that's called a permutation. So a permutation arranges a certain number. The order matters. Add that in here. Okay, so again, with permutation, arrange is a key word, and order matters. A permutation is a way of doing the fundamental principle of counting. It just doesn't use all of the information all the time. It's not complete multiplication. Okay, so 7 flute players are performing at an ensemble. The names of all 7 players are listed in the program in a random order. How many different ways could the players' names be listed? That is, arranged in the program. So if they're listed, this is a permutation. Okay, now remember, how many is a counting principle idea. It's not a probability. We're just counting how many different ways. Okay, so this is not a probability. So permutation, we have how many flute players. So our total number of flute players, if we scroll back up a little bit, is 7. Now, all 7 of them are arranged in the program. Okay, all 7 are in the program. So our R is also 7. Now, when your R and your N are the same number, this is where you have the factorial. So we can use 7p7, or we can do 7 factorial. Either way will give us the same answer. So 7, go over to probability, select number 2, and do 7. I get 5,040. If I use 7 and I do factorial, again, going to probability menu, selecting number 4, I also get 5,040. So like I said, when the R and the N are the same, you can use your factorial in a permutation and you'll get the same number for your answer. So our answer for this is 5,040. Okay. How many different ways could the players' names be listed in alphabetical order by last name? Okay, so this has a restriction, alphabetical order. Well, there's only one way to do alphabetical order. That's by the alphabet. So this is kind of a trick question. There's only one way to select this probability in alphabetical order. So if the players' names are listed in the program in a random order, what is the probability that the names happen to be in alphabetical order? Okay, so our probability event is alphabetical, alpha order. So our event, how many times can it appear alphabetically? Well, once, because there's only one way to do alphabetical. So 1 is our event number. What are the total possible ways to randomly arrange these names? Well, that's where we did the permutation up here. 5,040 or 5040. So out of 5,040. Again, you can put this in decimal form. but again, it might end up being too many zeros. So let's do that real quick. Yeah, we got too many zeros there. It goes into a scientific notation. So that would mean you'd have 4 zeros in front of that 1. So to keep it on a more accurate, let's leave it as a fraction. Okay, now after the performance, the players are backstage. There is a bench with only room for 4 to sit. How many possible arrangements, another key word, are there for 4 of the 7 players to sit on the bench? Okay, so this is a permutation because it's an arrangement. How many ways can we sit the 4 people on the bench? So a permutation from 7, choose 4. So this is not a factorial because the numbers are not the same. So we're going to go in here and we're going to select 7 over to probability, number 2, and put a 4 in there, and we get 840 different ways. So there's 840 different ways for the 7 players to sit on the bench. Now, that is the end of today's lesson. So just remember, permutations, arrange is a key word. Okay, that's a key word that happens, and the order matters. So it could also be officers in a group. If you select officers, the order matters who's selected. Just any kind of arrangement that you have where the order is going to make a difference in how it looks. Okay, have fun with that, and we will see you tomorrow.